All right, here we go with our topic 2-1 notes on slope-intercept form. So today we're going to be discussing one of the ways that we can represent linear equations, and that way is slope-intercept form. Before we jump into slope-intercept form, I first want to just go over a few definitions. The first is a linear equation. A linear equation is an equation that models a linear function. An example of this would be y equals 2x. The graph of this line would be the graph of this equation would be a line. Okay. The slope is the ratio of the vertical change to the horizontal change between 2 points, which we discussed in our previous notes, slope as a rate of change. Slope can be represented graphically as the rise over run. It is the ratio of the vertical change over the horizontal change. Or it's the ratio of y2 minus y1 over x2 minus x1. So remember the vertical change over the horizontal change, delta y over delta x. The y-intercept, we're going to be talking about that today in slope-intercept form. The y-intercept is the point on the graph that crosses the y-axis. The y-intercept is the point on the graph that crosses the y-axis. So if we're looking at this linear equation here, y equals 2x plus 1, the y-intercept is going to be that 1. So as an ordered pair, the point where it crosses the y-axis is going to be 0, 1. So notice the x-coordinate is always 0 for the y-intercept. That means that it's lying on the y-axis. Slope-intercept form is a linear equation of the form y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so let's go ahead and write that out. Y equals mx plus b, where m is the slope and the y-intercept is b. So now that we know what the y-intercept is, we can take a look at this up here. The coordinates for our y-intercept is always going to be in the form 0, b if we're given the equation in slope-intercept form, y equals mx plus b. Okay? So let's go ahead and discuss the following scenario. Alani wants to buy a $360 bicycle. She is considering two payment options. The image shows option A, which consists of making an initial down payment, then smaller equal size weekly payments. Option B consists of just making 6 equal payments over 6 weeks. What factors should Alani take into consideration before deciding between option A and option B? Well, option A has a down payment and then smaller, equally sized weekly payments. So if Alani can afford to make a larger down payment, then those weekly payments are much smaller and more affordable. But what if Alani can't afford that larger down payment? Then perhaps option B is the choice for her. She makes 6 equal payments. So they are a little bit larger than the equally sized weekly payments in option A, but she doesn't have to do that down payment at the beginning. So what factors should she consider? Well, can Alani afford to pay more upfront? So that would be option A, that making that down payment. Or are 6 equal payments more manageable? So these are some factors that Alani must consider. Can she do the upfront payment and then she'll have smaller weekly payments? Or should she just do 6 equal weekly payments? All right. Suppose that she could modify option A and still pay off the bike in 5 weeks. Describe the relationship between the down payment and the weekly payments. So how do the down payment and the weekly payments in option A relate to one another? Well, If she makes a greater down payment, so she makes a larger down payment, then her weekly payments are smaller because she has less to pay, and vice versa. So if she makes larger down payments, then she makes smaller weekly payments, and vice versa. So if the down payments are smaller, sorry, it's just one down payment, is smaller, then the weekly payments are greater. So depending on how much she wants to commit to up front, that will affect her weekly payments. All right. Let's talk about slope-intercept form. Go ahead and flip the page. So here we have slope-intercept form. As a reminder, that's y equals mx plus b, where m is the slope and b is the y-intercept. Okay? Let's take a look at each of these linear equations and determine which is the slope and which is the y-intercept. So this first one, we have y equals 5x plus 4. Our slope is that number in front of x. That's our slope, m, 5. So notice that it's just 5. It's not 5x, just 5. Our y-intercept is that number tacked on at the end. So here we have plus 4. That's our y-intercept. As an ordered pair, we have 0, 4. Let's take a look at this next example. Here I have y equals negative 5x plus 1. Our slope, again, is the number in front of the x in slope-intercept form. So we have our slope is negative 5. And our y-intercept is that number tacked on at the end, that positive 1. So as an ordered pair, we have 0, 1. Here we have y equals 1/2 x. Again, our slope, it can be a fraction. It's that number out in front of x. So we have our slope is 1/2. Now what's our y-intercept? I don't see anything tacked on at the end. Well, if there's nothing tacked on at the end, you can assume that we've got like a plus 0, right? That doesn't change anything. Our y-intercept is not there, it's 0. So our y-intercept here as an ordered pair is the origin, 0, 0. Now let's take the slope and y-intercept and put that into an equation in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where m is the slope. So we have y equals m, negative 1/3, x plus b. Well, b is our y-intercept. That's just the y-coordinate, where x is 0. So plus 7. Notice that I have the x out to the side. You can have the x in the numerator or in the side. Do not have the x in the denominator. That means something else. All right, let's try this one. We have a slope of 2 and a y-intercept 0, negative 5. Let's plug that in. Y equals mx plus b. M is our slope 2, so 2x plus b. Well, b is negative 5. You could say plus negative 5. I find a good practice to say just minus 5. Either way is good. I'll accept either answer. Okay, so now we have slope of negative 6 and the y-intercept on the origin, 0, 0. So y equals mx plus b. M is negative 6, so negative 6x plus b. Well, our y-intercept is 0, so we could write plus 0, or you don't have to write anything at all. You can just leave it as y equals negative 6x. All right, let's go ahead and graph lines in slope-intercept form. So let's start off with this first one. We have y equals 1/4 x plus 1. I really like graphing lines in slope-intercept form. I find it really easy to graph them. So let's start off with identifying the y-intercept. Well, the y-intercept in y equals mx plus b is our b. That's that number tacked on at the end. So our y-intercept is 1. As an ordered pair, our y-intercept is 0, 1. We're going to use the slope to plot more points. Let's first plot the y-intercept. So we have 0, 1. We look at this, we go right and left 0 and up 1. So that's going to be up 1 on our y-axis. Okay, to use our slope to find more points, let's first determine what our slope is. Well, our slope is that number out in front of x, so that would be our 1/4. We know that our slope is our vertical change over our horizontal change. So let's take a look at this point here. Let's use our slope to find our second point. Well, positive 1/4 tells me I can go up 1 and right 4 from that first point. Up 1 and right 4. Remember, that's our vertical change, positive 1, over our horizontal change, which is 4. So that tells me up 1, right 4. All right? And we can continue doing this from our second point. We can, again, go up 1, right 4. We'll plot another point. And we could keep going. We could go up 1, right 4, up 1, right 4, and just keep plotting infinitely many points. So how many of these can you plot? You can plot infinitely many. Unfortunately, our graph doesn't support infinitely many. It only supports up to x equals 10. But theoretically, you could just continue plotting points on the line. All right, go ahead and take out your straight edge, whether it's a ruler, the edge of your ID. Sometimes the top of your calculator case is good. We're gonna, oh, that was terrible. We're gonna connect the dots here. Make sure your line goes through your points here. There we go. And then at either side of our line, we're gonna draw in our arrowheads because this does extend infinitely in either direction. Okay. Make sure your line also takes up the whole grid. I see a lot of lines that end here. Make sure you extend it all the way across the whole grid. All right. So that's graphing a line in slope-intercept. Remember, we plotted the y-intercept, 0, 1, and then we use our slope to find our other points, up 1, right 4, up 1, right 4, and so on. Let's try a couple more. So number 3, we have y equals 3x minus 7. Well, the slope is the number in front of x, so we have 3. I always like to represent my slope as a fraction, just so that I can see the horizontal change and the vertical change. So 3 as a fraction, we can always put it over 1. So we have 3 over 1. So this is going to tell me up 3 and right 1. Okay. Our y-intercept, we have minus 7. That's that number tacked on at the end. Our y-intercept is 0, negative 7. All right, so to graph this, we start with our y-intercept, 0, negative 7. Let's plot that point. So we count down 7 on the y-axis. And then we use our slope to find our other points. So here's our slope, 3 over 1. So that tells us up 3, right 1. So from our y-intercept, we're going to count up 3, 1, 2, 3, and right 1. We can continue up 3, right 1, up 3, right 1. And again, you could continue doing this as many times as you want. I recommend having at least 3 points. All right. Use your straight edge, ID, your calculator case, a ruler, anything like that to draw on your line. That was much better. And don't forget those arrowheads. This does extend infinitely on either direction. Okay, so that's our line. We did it. Let's try one more. So here we have y equals 1 minus 2/3 x. Now this is not in slope-intercept form yet. Remember, slope-intercept form is y equals mx plus b. We can think of this, the 1 minus 2/3 x, as a sum of terms. So as long as we keep the signs of our terms straight, we can rearrange these terms. So we can say that we have y equals negative 2/3 x plus 1. That one is positive. So y equals negative 2/3 x plus 1. So I find it helpful to rewrite the equation in slope-intercept form. All right. So the slope here is that number in front of x. We have negative 2/3. And then our y-intercept, we have positive 1. So as an ordered pair, we have 0, 1. All right. So to graph this line, we always start off with the y-intercept. So 0, 1, we're going to count up 1 on the y-axis. That's where it crosses the y-axis. And then our slope, we have negative 2/3. Well, I can say that this is down 2 and right 3. We could say that this is the same as negative 2 over 3. So down 2 and right 3. All right, vertical change over horizontal change. Down 2, right 3. We're going to go down 2, right 3, and we can continue. Down 2, right 3. Again, I recommend 3 points at least. You can continue as long as you want. But let's go ahead and connect the dots. And we get this line here. Don't forget those arrowheads, and don't forget to extend your line through the grid. All right. So this is slope-intercept form. Remember, y equals mx plus b, where m is the slope, y and b is the y-intercept. We graph using the y-intercept and then find our other points using the slope. All right, we're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day.